Okay, let's discuss something I find very interesting. Let's discuss about finding extreme points like the minimum and maximum values on certain types of functions, and how can you use the things that we have learned about the derivatives in order to find them more easily. So let's say I have a graph. This is the y-axis, this is the x-axis, and I have a function that goes something like this. Okay, so let's find the minimum and maximum points. So the minimum point would be the point where the y value is the lowest, so let's call it this point A, and the maximum value on the function would be, let's see, yeah, it would be this one, so this point here. We can call this function f of x, and this point B. So we can state that f of A is smaller or equal to f of x for every x in the domain of this function. And for f of b, we can state that it's bigger or equal to f of x for every x in the domain of this function. Okay, now let's look at these points here. Let's call this point C, let's call this point E, and let's call this point G. What can you notice about these points? Now we have, let's say, a certain domain that's near the value of the value C. We can say that C is a local maximum point, where the value of f of C is bigger than any either value in that domain, and that domain would be for values very near to the value of C. We can also say that for the value of f of E, that is a local minimum point. Also for the value of f of g, this is a local maximum point, since f of g is bigger than any other value of x in a certain domain. Let's say this is the domain, and f of g has the largest value. We can also say that for our maximum points, for our absolute maximum points. So f of a is not only a absolute maximum point, but it is also a local minimum point. My bad. Also, f of b is not only an absolute maximum point, but it is also a local minimum point. Now, how can we find these points easily? Now notice something. How can we find actually local points, local extreme points, which are local maximum or minimum points? Now if you notice here, the derivative of the function at the local minimum or maximum points is equal to 0. So let's see, we know f of c, let's say f of c, f prime of c is the derivative, and it is equal to 0. So this has the potential to be either a maximum or a minimum point. The same can be said for f of e. F prime of e is equal to 0. So this can be a local extremum point. Now, also the same can be said, for instance, if we have if we have a absolute a function that's f of x is equal to the absolute value of x. Now here, this is the minimum point where the y coordinate is equal to 0. But be careful, we cannot say that let's call this point C, that f of C is equal to 0. We cannot say that since we cannot define the derivative here. So f of C does not exist. So what can we take from this? Well, local minimum or maximum points are found where the derivative of a certain value is either 0 or does not exist. And these points are called critical points. Now be careful. Not all critical points are local minimum or maximum points. For instance, if you have something like this, let's say we have a function f of x is equal to x to the third, and we'll have something like this, and let's call this point C. Now the derivative of f of c is equal to 0, but this is a critical point, but it is neither a local minimum or local maximum point. So be careful when you're finding critical points. Not every critical point is a local minimum or local maximum. Now let's solve an example. Let's see. We have f of x is equal to x squared over x minus 1. And we need to find the local minimum and maximum points. So I'm running out of time, so this will be quick. So f prime of x will be equal to what? We need to use the quotient rule here. So I'm just going to write this since we don't have a lot of time. Minus x squared or x minus 1 squared. And this can be simplified to x times x minus 2 or x minus 1 squared. Okay, so we need to find where the derivative is equal to 0 or it is not defined. So where does f of x equal to 0? Where when x is equal to 0 or when x is equal to 2? And where does f of x is not defined? Well, it's not defined at the value of x is equal to 1. Now be careful. We cannot say that the point f prime of 1 is a critical point. Now why? Well, if you notice here, neither the function, neither the derivative are defined at x equals 1. So what we can take from this is that critical points are found that when the derivative is either equal to 0 or either is not defined, but we need to be careful to check if the function is defined at those values. Like in this example, even though the derivative is not defined, this is not a critical point since the function is also not defined at that particular value.